In Python, you can create an empty set using the set constructor. Remember that you can't do this using curly brackets because Python will think that's a dictionary. However, if you have a few items in that set, then you can directly just use curly brackets. So here I have this fruit set, and the reason that you would choose a set as opposed to a list is mainly for membership check. Sets or dictionaries are very efficient at finding the members. Here, I'm checking if apple exists in this fruit set, and it does, and I'm checking if coconut exists in the fruit set, and it does not. The difference between doing this operation in a set as opposed to a list is that in a set, this will cost you O of 1. Basically, because we use hashing, and if you're not familiar with hashing, imagine just a one-to-one mapping that apple is mapped to a specific address, orange is mapped to a specific address, and if we have like something like coconut, its address would be something, so Python will just check that address that would be generated from coconut, and if it doesn't exist, then it will determine that that item is not a member of this set. As opposed to when you're doing membership check in a list, Python will have to go through the items of the list one by one to figure out if that item is a member of that list or not. So for a list, it would cost you O of n. For a set, it would cost you O of 1 to do membership check. Another attribute of a set is that it doesn't have any duplicate members. Here I'm defining 2 extra apples at the end of this set, and if I print it out, you see that there is no duplicates in the set. Sets similar to lists also have a length. The difference is that in a list you have indexes, but in a set there is no concept of order. For sets, similar to lists, you can put different data types in the same set. Here I have a set that has an integer, string, a boolean, and a float, and Python doesn't have an issue with that. Another use case for the set constructor is that you can convert other data types to a set. Here I am changing a list to a set. You could use a tuple as well. And here I'm changing a string to a series of characters. And notice here, although I have 1, 2, 3, 4, 5, 6 characters in banana, I only have 3 down here. And that's because set basically filters anything that's duplicate. Sets have a number of built-in methods that we're going to go over. Here I'm starting with that same fruit set, and I'm adding cherry to it. So now I have all the existing elements and cherry. And notice that there is no order here. So cherry got added over here, and there's really not a concept of index here. Remove does the exact opposite. It removes an element from your set. We also have this other method called discard. Discard does the exact same thing as remove. The only difference is that when you're using remove, if that item doesn't exist in your set, Python will throw an error. For discard, if that item doesn't exist, Python just moves on. So here, pear doesn't exist in my fruit set, and Python will throw an error. But if I were to use the same, basically remove pear using discard, I could do it, and basically nothing happens to the set. The last method for this section is pop. And pop just randomly removes one element from your set. So unless you are trying to randomize some experiment, it doesn't make sense to use pop. There is a common mistake when working with objects in Python, and that's the difference between changing the reference or changing the object itself. Let's talk about copy and clear to explain this. I have this set called set1, and it has 1, 2, and 3. If I want to create another set, you may think that I could do set2 equals set1, and now I have these 2 sets, and they're the same thing. If I add a number to set1, set1 has 4 now, and so far so good. But set2 somehow behind the scenes also received that 4. The reason for that is that when I assign set1 to set2, I'm just creating another reference to that same object. So if you look at this picture up here, both of these, set1 and set2, are pointing to the same object. So if I add 4 to this set, then both of them will be impacted. Now, what I really wanted to do is to copy this set, basically to create a clone of that original set. So let's start from the beginning and try this out. I have set1, which is 1, 2, 3. Set2 now is a copy of set1. Now I add 4 to set1, so set1 still has 1, 2, 3, 4. But here, set2 now only has 1, 2, and 3. So what happens behind the scenes in this case is that when I write set2 equals set1 copy, a clone of that set is created and is assigned to set2. A somewhat similar scenario happens when you're working with clear. Here I'm starting with set1, which is 1, 2, and 3, and then assigning that to set2 as well. Now, if instead of clear, I try to just assign an empty set to set1, you see that set1 is now an empty set, but set2 still is pointing to the old object. So still items did not get cleared out. But if I use clear instead, let's start from the top again. So set1 is 1, 2, 3. Now set2 is also 1, 2, 3. Now I only clear set1, which is making the change on the object. So now set2 is also pointing to that same empty object. So the difference is that in the first scenario, I am changing where this set1 is pointing to. So set1 is now pointing to an empty set. In the second scenario, I am making the change on the object. So I'm basically deleting all these elements that were in the set and not changing the references. So now both set1 and set2 are pointing to an empty set. Here I have 3 sets. Nums has the numbers 1 to 5, evens has the even numbers in that range, and odds has the odd numbers in that range. If we try to visualize this, it looks something like this. Nums is a superset of the other two, and odds and evens don't have anything in common. We have a few built-in functions to help us determine such functionality. Here I'm seeing if nums is superset of odds, and it is. And then here I'm checking if odds is a subset of nums, basically if all of the elements in odds are also elements of nums. And also I can check if two sets are disjoint, basically if they have no elements in common. So we know that odds and evens don't have anything in common. And also just to show you a false scenario, here I'm checking if odds is a superset of evens, and we know that it is not, so I see false. An alternative to the English version is to just use the greater or smaller, or greater and equal and smaller and equal format instead of writing it out. So here I'm checking if odds is a superset of odds, so this will give me false, but if I do odds greater or equal, this will give me true, because every set is also its own superset. Or I can also check for if a set is a subset of another one, so I know that odds is a subset of the nums set, so this will return true. Here I have 2 more sets, and one of them has 1, 2, 3, the other one has 2, 4, and 5, and the picture shows how the elements are distributed. So 2 is in both of them, 1 and 3 are only in A, 4 and 5 are only in B. Now we have some built-in functions to help us when we want to compare 2 sets. Union will give you all the elements in both sets, and you can either use the English format, union, or you can use a pipe. So this is basically 1 to 5, all the elements. Intersection will only give you the elements that are common for both. And again, you can either use the word intersection or you can use and. Difference will look at the first set and remove anything from that set that exists in the second set. So it's kind of like you're subtracting the elements that exist in the second set. So you can also just do A minus B, which will result in the same thing. And symmetric difference is the same as exclusive OR. So we are only looking at the elements that exist in one or the other, but not both. So if we take a look at this picture, 2 exists in both, so we're not going to include that, but the other 4 exist only in one of the sets. So symmetric difference is pretty much just another word for exclusive OR. For all the built-in methods that I just mentioned, there's also an update version of it, which basically puts the result in that first set. And they're not really worth memorizing. You can always look them up, or you can, watch this video again. So here, update will basically take the union and put it in A. And an alternative of that is to just write A equals A union B. And the short form of it is something like this. So basically union equal or an operator equal puts the result in A. And you have the same thing for intersection difference and symmetric difference. And these are all the short formats that are exactly the equivalent of those operations. Similar to list comprehension, we can also have set comprehension, and it is exactly the same way. So here I have a set that is 1 to 9, and I can dynamically generate that by using a for loop. So here I'm doing I from range of 1 to 10, and you know that that last number is not included, so I'm going from 1 to 9. And if I wanted to change this so I can only get the even numbers, I could do I for I in range 1 to 10 if I modulo 2 is 0. So that makes it easy to dynamically generate a set. If you're preparing for interviews, take a look at the question that I've selected for you in the description. Best of luck.